Good afternoon, everyone, or good morning to when you are. Just want to start off by saying thank you for New Stars Data for giving me the opportunity to have a talk. Thanking Marco as well, my mentor on this, really helped me kind of get us all together and really define the talk. But further ado, let's get started. As I just said, I'm going to talk to you today about model creation in Azure AutoML, which is Microsoft's offering of kind of automated machine learning and machine learning in general. And then kind of the goal then is to show you how we can use a model. At the end of the day, it's great to create a model, but it's also useful to show how you can get it in the hands of your end user. Just to start off then, and kind of elaborate on what Ed just introduced to me, who I am. If you're interested in linking up with me, I've put my LinkedIn there as QR code as well, which will take you straight to my profile. My Twitter, I'm not so active on there, but I do go on now and then. If you want to follow me on there, I do kind of share some articles about machine learning, and just kind of comment on stuff's happening in the machine learning world. And then my work email, if you want to connect to me, have a chat, just talk about anything ML projects, go for it. And so, as Ed said, I'm a machine learning developer at the moment for Purple Frog Systems, based in the UK. Purple Frog, kind of a data analytics company in terms of setting up databases up, setting cloud databases up, analytics, and advanced analytics and machine learning. I'm a certified Microsoft Data Scientist Associate, and I said 4 or 5 years experience working with data, primarily through R, VBA, and Python. And then recently really came into the Microsoft stack when I moved to Purple Frog Systems. Historically, did a lot of work in R when I was working in life insurance as a quantitative analyst. So that's a lot of financial modeling. And also I had a stint as a VBA developer in that same company, just developing tools in VBA, just to kind of automate processes, etc. So contents of today's talk, what we're going to go through. I'll start off with what is machine learning. I'll give you a dictionary definition there, but also I'll kind of break it down to more simplistic kind of viewpoint what it is, and give you the raw bones of what machine learning is in my opinion. And I'll also make the comparison to AI, and just show what the actual difference is between the two. I think that's quite important. We'll then talk about what AutoML is. I'll briefly go into kind of the core value of it in terms of what it really is, because it's not automating the whole process, and we'll go into it when we get to it. We'll then discuss who should use AutoML, who is it useful for, and what uses have different types of users, and then what problems can it solve. When we say problems, kind of what work cases are viable to be put through AutoML. I'll then discuss common workflow of a machine learning pipeline, and just show you where AutoML comes in and how it's useful in that kind of cosmos of the workflow. And then I'll take questions. I'll also supplement this with 3 demos along the way. The first being here. This where I'll take you through the Azure Machine Learning Studio. This is the GUI interface for Microsoft's offering in terms of using its machine learning capabilities, and it's also where it's housed their AutoML. And then the next model will be down here, where I'll go through kind of the meat and bones of what we're going to do today. So data ingestion, how we set up a run, understanding the metrics and the output you get from running an AutoML model in Azure Machine Learning Studio. And then I'll also show you an example of a fully code-based environment. So the AutoML Machine Learning Studio kind of version will be a no-code example, which I'm going to push you today to show how easy it can be. But also, just for your interest, I'll show you how you can do it all code using our Microsoft example in VS Code. And then the last demo will be me showing you how we can take the model once we've exposed it and put it in the end user's hands in Excel using some pretty quick and hard and fast VBA. So talking goals, what I want you to achieve from listening to this talk today, I would like you to walk away being able to explain what machine learning is. I'd like you to walk away explain what AutoML is, and I'd also like you to understand and be able to explain to someone how we can use the models we create and put it in the hands of an end user. So let's get started with the nitty-gritty. So what is machine learning? As I said, I've given you a dictionary definition there. Study computer algorithms that improve automatically through experience and using data. What does that really mean? So machine learning, we have data, we have past data. Arguably, the more the better really there. But we're taking this data and we're giving it an algorithm, and that's going to look at the data, and it's finding the relationships, it's finding the nuances, it's finding how these data kind of talk to each other and how they impact what we're trying to predict. So, example, if we're trying to predict if someone should have a loan or not, yes or no, all that supplementary data, and the algorithm's going to take away these computations. It's going to make a network of decisions and kind of show that framework as a model, and that model could be used then to make predictions on future data of a similar format to well, exactly the same format, should I say, as the data we fed in. So to summarize that, it's machine learning is taking past data and kind of using an algorithm to find the relationships and nuances in there, which allow us to then make a framework to make predictions from. As I said, this is different to what AI is. AI is a kind of a field of which machine learning is a branch of. And if we were going to define what AI is, strict speaking, it's an agent interacting with an environment to meet an end goal. So I like to speak about Tesla in terms of this, in terms of an autonomous car, and the car is the agent, and that's having interactions environment. It's communicating, it's taking information, and it's making decisions there via interacting and on the fly, gathering data and working out how it's going to get to an end goal. So in this case, how it's going to navigate from A to B without crashing and keeping the user safe in the car. So I see the difference here is with machine learning, the data is old, it's learned off it already, and it's implemented on new data. With AI, it's interacting actively and actively making decisions on the fly to then kind of interact and make that end goal. And it's coming so the fact that machine learning is getting bigger and bigger now, and it's kind of coming to its own field, separate to AI. And people try to use these terms interchangeably, and it's arguably it should be done. Machine learning is very distinct in terms of what I just said, in terms of the difference between the two. So moving on to what AutoML is. It is what it says on the tin. It's automated machine learning, but it's very specific in what it's automating. So in the core element, to me, it's a time-saving tool, and it automates the most time-consuming and iterative task of machine learning model development, which is the part where we're trying many different algorithms, hyperparameters, and pre-processing as we go through. It's what the data is given to. To just get the definition of hyperparameters there, if we say each algorithm's kind of an old FM radio, maybe with that, and the hyperparameters are stuff we can adjust to kind of tune in and optimize the model. So if that makes sense, so an algorithm, hyperparameters sit on top of that is stuff we can adjust within the algorithm to fine tune it. And pre-processing is stuff that we do to data, such as scaling, filling in missing values, etc. And so AutoML goes in and it does this for you. It goes through and it does a lot of iterations and different combinations, some of which take me personally a lot of time to go through code and do myself. And it's why it's such a valuable tool. I think it's something, even if you are very experienced kind of data scientist, machine learning developer, it's useful because it saves you a lot of time. So moving on to the first demo, I was hoping just to run through the Azure ML Studio now in terms of the interface. So let's pull that across for us. Okay, so this is the Azure ML Studio. I said to the home screen, so as soon as you log in, you set the resource up. Just to say this point here, I have put links into this to blogs, which go through how to set up Azure Machine Learning Studio as a resource. So any bits you think are missing in terms of what I'm talking for this, I've jumped a bit. The blogs will go through that in detail. I've got links at the end, just to save time in terms of I've got an hour to get through this all. I've kind of skipped that bit and gone straight to this, but the information will be there for you in the blog links I put at the end. So we'll stop all of the Azure Machine Learning Studio. So when you first open it up, it gives you a link to stuff you've done previously and most recently, kind of hyperlink stuff you've done recently. The most important part on the side here. So notebooks, this is where you can go through, and if you're familiar with Python and C++, you can do all the work through there in terms of doing your machine learning experiments and running your AutoML. This is the AutoML tab. So this is where you kick off AutoML jobs, and we'll come through back to this later on when I go through the whole process of running an AutoML job. Those who've looked at ML Studio before will understand Designer, and this used to be the original offering of ML Studio in the beginning, and it's kind of a click and drag pipeline environment to do your experiments with. It's not something to use anymore, but it's still there and usable. But going on to the main tabs now, so data, this is where you're storing all your data to use in Azure ML Studio, and it's also where you can ingest your data via a GUI. Jobs, these are experiments you've run. It keeps a track, so you can do a lot of runs under an experimental branch and do comparisons there. So that's where they're all housed, and you get links to go through to your models, etc. After you've ran them all. Components I've got into, pipelines. This is where you kind of set up repeatable experiment and stuff. So when you're trying to implement a production model, you can kind of set it up here. It's not something I go into today, to the bare bones. It's environments, the stuff they've already set up for you, kind of optimize stuff with certain versions of packages and stuff in Python. You can call upon and use models. As I said on the tin, this is holding all your models that you've chosen to keep and register. So you can go back to them, and it's the interface. You can see, click on them, go through, see how they did, what data was using, where have you deployed it, if you deployed it. Endpoints. So these are the models you've exposed. So the models you've got and you've deployed. Yeah, we'll go for that again later on in terms of when I get onto the demos, the big chunky one. And the next really important bit is your compute resources. So this, you need to have a compute resource to do anything in the Azure ML Studio. So this is the kind of brains behind it, the thing that will be doing the calculations and we're doing the decisions making. So it's based really on a lot of variety in different computes you can have underneath in terms of the one instance or clusters. The default is a standard DS3 V2. I think it's the second cheapest to use, but it's what they will show you to use when you're trying to when you go to set up a compute instance. Once again, the blogs I'll link at the end will go through the setting up of a compute instance. So I'm not going to go through that today, but the information is there for you if you're interested in the blog links at the end. So going back to the presentation, who should use it? Who should be using AutoML? And the brief answer is everyone and anyone should use it. So everyone can use it and anyone should use it. I said it makes machine learning accessible for all. For newbies, it's a great access point. As I said, I'm going to show you a no code example this morning. And it doesn't really require that much ML knowledge in terms of algorithms implementing them, because it's doing all that work for you in the bits it's automating. It's a learning tool, so you can see under the hood, so to speak. So I'll show you when we get to the model creation bit and we create a model, you can click through and see the Python script that you can run, which would do what AutoML's done for you already. So you can go through and see if you want to learn the Python code appropriate, but you also see the iterative thought process and common practice, good practice for code in Python. It's not the most streamlined and kind of Python scripts. It's a bit convoluted in parts, but it's really good. It's good for learning from. And as I said, you see under the hood and learn from it. I said it allows access to ML Studio for all. It kind of opens the gates and stops it being a black box, kind of people being scared to get into ML. It gives you a stepping stone to kind of dip your toe in the water, which I think is great. And for the more experienced user, it's a time saver, as I'll keep saying, and I'll probably say a couple more times. It's automating the most time-consuming part of the workflow, and so as an experienced user, it's a great kickstart to any project. You get introduced to new algorithms. So even the most experienced ML data science user isn't up to date with all the algorithms there. And there's been a couple of times when I've run out of AutoML and I've gone, oh, what's that algorithm? I've never heard that before. So again, you can still learn from doing this to a degree. It's quite fun when you do come across a new algorithm to go through and understand it and experiment with it. And once again, it can be used via code through VS Code extensions, and arguably it's more powerful to do so. And I'll talk through a few points as to why that is the case when I show you the VS Code later on. So what problems can it solve? There's 5 main cases. The first 3 are readily available, and the last 2, while a lot more exciting and a lot more promising than they're in preview. So currently, classification problem. So example here is a binary classification, which I'm going to show in the demo later on. Not a specific example, but what I've given here is yes or no to a loan. So a lot of people, you may have done this kind of when you're online or you see adverts, you get a decision in 10 seconds. And what it usually is, they're asking you a list of questions, which is giving data to a model in the background, which then make a prediction of a yes or no to you being approved for a loan or not. So that's an example of a kind of a classification model being used in day-to-day life. The next is a time series. So this is a kind of a variable against time. If you think of it, so oil prices over time, and the end goal of this kind of predict future oil prices. So if I gave it 10 years worth of US gallon price, I want to know what it's going to be in the next 3 months. It can come back and say, well, 1 month from now will be this, 2 months from now will be this, 3 months from now it should be this, and I'll give you a degree of accuracy on that. And a regression problem. So it gives you an output on a continuous numerical scale. So I've put here predicting store sales. So if a customer come to you and said, I want to know if I open a new store, what profit will it have in the first year? So you can feed in all the store data they've ever had for that company, and the regression model you get from the AutoML will then give you a prediction based on any new data of a new store. And then the last 2, which are in preview at the moment, is natural language processing. So a natural language is anything that's come through naturally. So it's been produced naturally via human interaction and culture and history. So English, French, Spanish are all natural languages. Something like Simlish from the Sims game is not a natural language, so it wouldn't be able to do that. but it's getting to create quite a big field at the moment, a fun field of that. So the example I've given here, if you've given a natural language processing model to train 200 scripts, and you want to know the genre of a new script based on that, it can tell you, and you can feed it a script and it'll say, I think it's a romantic comedy, I think it's just a romantic film, it's a horror. That's the kind of output you can get from this. There's other stuff, there's sentiment analysis. If say on a review site, if someone's being happy or sad, they're being negative or positive, that's additional stuff it can do as well. And you've got computer vision. So a great example is if you feed in 10, 20, 100 pictures of dogs, cats, and monkeys, any animal, and saying what animals in these pictures, the model will build up identification of what a dog is to say, and you can give it a picture of a dog and it'll say there's a dog in this image. If you give a picture of a dog and a cat, it'll say there's a dog and a cat in this image. So this can be useful in industries such as factory production lines in terms of identifying parts which are wearing out or in need of being changed, and kind of being proactive based on just putting a camera next to it, taking a picture every half hour. You can say, well, this needs changing now, and you can avoid factory downtimes. So that's an example of how you can use computer vision in the real world. The only problem is the last two is they require a GPU compute instance or cluster, as it is very computationally heavy to do these two. So when I say GPU, as a graphical processor unit, as opposed to what you're probably more familiar with as a CPU. And the only reason for this is that GPUs are a lot better at the calculations which occur in machine learning compared to a CPU. So most on-prem GPU kind of machine learning rigs will have a lot more put towards GPUs for this very reasoning. Okay, so moving on to the next demo, the big one. So I'm going to show you now for the Azure Machine Learning Studio how we can get data in, how we can set up an AutoML run, then get that running, and then understand the output thereafter. And then I'll also pop up some VS Code examples, which I've taken from the Microsoft website, just because it's kind of, they're very in full, and it's kind of a useful framework. And I'll go through and I'll point out bits and pieces which I'm kind of showing you where that connects to the demo I'm going to show in a second, and how it can be better to use VS Code if you're a more experienced user. Okay. So I get up this again. Find my mouse, there we go. So if we start off with data, if we want to get data in, so what we're going to be using today is something called the diabetes dataset, samples dataset. This is an open dataset that Microsoft has. I'll go through in a second, but just a bit of background on the data. It's 10 baseline variables from 442 diabetes patients. And in there we have age, sex, BMI, blood pressure, these 6 variables, which are blood serum measurements. So it's just stuff that's in the blood, and Y is kind of how far the disease progressed 1 year after a baseline. And you'll note in here, it doesn't actually say if they have diabetes or not, which if we were going to do a classification problem, usually are more useful to do. But today we're going to be doing sex. And we're going to predict, based on all the data in there, if a patient is male or female. So how would we get this data in? It's simple as clicking this create. If you have the data locally, you click this local files, you give your data a name, and it's literally a browser extension pops up, and you go through your local browsers and to your data, you double click it, it'll upload it. It'll check some schema and stuff in there. again, all the nitty-gritty of that bit is in my my blog, so you can link at the end. But as we're using a open data set today from Microsoft, we want to click here, and you've got them all here. There's a lot here. The diabetes data set is here, so you click it, you go next, you give it a name, and you click create, and you've got the data set there. Very simple, very easy. And as I said, I've already got it in here, so we can click that, open it up if you want to explore it. So you've got metrics in here, just general attributes. So how many files in this data set? We've only got one, but you can have multiple. What version of data set you're on? This is more useful if you're uploading your own data set. It's in terms of archiving and just keeping a track of any changes you've made between. And you can go between versions. You can upload new versions. Just a way of keeping all your data in there. Consume, if you're going for a code-based kind of route, it gives you the code in Python already to bring your data in, so that makes it really useful. And then explore is probably the most useful bit in terms of getting a feel for your data initially. So it gives you a table of everything you've got in that data set, and more importantly, when you upload it, it gives you a profile of your data. And each feature variable you have in there. It gives you histograms as well, so you can see kind of how your data is sitting, how it's spaced out. It gives you min maxes, your interquartile ranges, your variance, your kurtosis. More information you really need, but it's useful to just get a feel of your data. And when we come to talk about the common workflow of machine learning, I'll go into why it's such a vital part of the process to kind of look at this kind of stuff and to kind of assess your data in detail and understand it. So we've got our data in now. We've looked at it. We're happy with it. We've got a feel for the data, and we want to run our AutoML job. So you click here on the AutoML tab, and we want to start a new job. So we push here, new automated ML job. Okay, so you want to select the data you've already got in, the sample diabetes data. You can bring data in here, but I'd prefer to go through the normal route, probably best practice. But to bring the data in, you're clicking here, sample diabetes, and you press next. Okay, so here you can either add it to an existing experiment. I said so jobs collaborate into an experiment. So if you're doing multiple jobs where you're varying high parameters, etc., or varying underlying data, see difference at the end, you can bunch it all up in one experiment. But usually, if you're doing a little AutoML job just to test the data out, you want a fresh experiment each time. So let's call this test 2. And then it wants to know what your target column is. Now, it does give you kind of instance of what it means by this here. And as what it says in the tins, it's what the model will be trying to predict. So in here, as I said earlier, we want to predict if someone's male or female. So that's going to be sex. And then also you want to pick our compute. So as I said earlier, we've got a compute instance set up, it's running, and you want to say, I want to use a compute instance here. And then you want to pick which compute instance. So I've got one called delete, so I remember to delete it later on. So that's all set up, and we click next. And this is where we go on to.
This is your half-hour reminder that you asked for, so you have a half hour remaining.
Okay, that's great. Thank you, Ed. Cheers. So here is when we're selecting from which kind of problem we're trying to solve here. AutoML is quite smart in terms of from the data we've put in and the target column we've selected, it knows because that target column of sex is either a 1 or a 2, male or female. It knows we're probably going to do the classification there because we've got a binary selection in terms of the target column, and it's correct in thinking that. But in case where it is wrong, you kind of come through and you can click what you want to use instead. But it was correct in saying a classification problem is what we're doing today. So we'll keep that selected. And then we want to view additional configuration settings. Okay, so go briefly for this bit, primary metric. So when AutoML is doing its automation and going through the bits earlier in terms of different combinations of algorithm, hyperparameters, and pre-processing, it's going to use a metric to assess how well each model is performing in terms of how it's going to move on and do more iterations, how it's going to adjust itself as it goes through iteratively, but also in terms of how it's going to rank the models it's created, which is the best one and which one is going to kind of show to us and say, this is our best one. So there's a lot of metrics here to go through and do it. I've got AUC weighted on there, which I'll discuss what that means later on. But in terms of your choice here, it's better to keep it what it's defaulted to. At the end of the day, it's the same difference, really. It's just down to preference, really, here. So there's not much in terms of messing about with this. You can also choose models to block. So you can tell it which models you don't want it to use. If you've got some knowledge of ML in the background, you know these aren't going to be of use to us. I know for a fact they're going to be. So I don't want AutoML to waste its time using them. You can put them in. But use this kind of experiments, it's okay just to leave as it is, and AutoML will split the difference and kind of it'll find out that those models aren't that effective and get through them pretty quickly. But the only thing we really want to change here is exit criterion. So currently, AutoML will keep running for 6 hours. And if it keeps making improvements, it will run for the whole 6 hours. If it gets to a stage where it's not making improvements, the private metric, it'll cut off. But it is the case, it could go for 6 hours, and it could be a costly experiment. So if we're playing about and experiment with stuff, the lowest it can go is half an hour. So if you're playing around with this and kind of doing a baseline model, half an hour is great to use, and I suggest setting this to half an hour if you're going to go through an experiment. So half an hour, save that, we're done. We then click next. Okay, these are two quite important kind of variables to set, but also concepts to get your head around. So when AutoML and machine learning in general, when we set an algorithm up, we don't train it on all the data we have. So what we do is we make a training set and a test set, and the model will be trained on the training set. And then once it's done, it will come and it will try and predict the test set. So in this training set, we'll have all the data along with sex. With the test data, we'll have the sex, but the model won't know that. And this is how we get the metrics in terms of how good the model's being. It's from this testing set. So it makes predictions and it compares it to the real answers. So the usual split for this is we'll go for 80% of the data you have being a training set and 20% being a test set. And that's just kind of a number that's an industry standard. It's a good amount of having enough data for it to train on, but also leaving enough that we're getting good tests in the model. So how we set up is a test split here. I said you can choose that no test data is needed and it'll train on everything. I wouldn't advise doing so. You can provide a whole different data set as well for the model to be tested on, but usually the practice is to do a test split, and you set this 20. So your test data will be 20% of the data. Now, validation type. This is how the model is going to test that the numbers it's giving and what it's saying is the accuracy and performance of the model is true. So for an example of this, we could be doing a test split of 8%, but all the patients from our diabetes data set that have got into that 8% training split are all male. And the model will have only learned to identify a male there. So it'll come through and the testing will say, well, this model's pretty pants, actually. It's not great because it's miscorrectly identifying all the female patients. in testing. So to get around this, it does a validation. In terms of the best one to explain, is a k-fold cross validation. And what it'll do kind of the training k amount of times, so 4 or 5 times, but each time it's going to take 80% and the 20% training and testing split again. So it's going to mix it up, take that 80-20, do it, give us a performance, mix it up again, get another 80-20, and give us the performance again, and you get an average. So it's useful to know that kind of this validation is happening in the background, and it gives you more confidence in the models you're outputting. But I just wanted to get across the concept there. I wouldn't change this unless you really kind of know the nuance between it, and you know for a fact that all those different validation types are going to be more useful or not. Okay, so I'd keep that auto because it's all the same difference really at the end of the day. So the next bit of this would be to click finish, and it will set the experiment up and it'll run in the background. We're not going to do that today because we've got an experiment that's run. So we'll click cancel there. I'll go to this job we've run already. So this is the model that was outputted by the job. So this is the best model it had, and it's what it came back to us. And this is kind of the metrics we have for it here in terms of how it's performed. And we can see particularly just information about the model. So it's a voting ensemble. AutoML will almost 99% of the time give you an ensemble method model. And what I say by ensemble, it's a mixture of different algorithms. So here it's a mixture of, let's say, 10 or 11 algorithms here. They're kind of each doing their bit and making a prediction. And as an ensemble coming to a prediction, it's usually the most powerful. But in terms of if you were doing this by yourself, it's probably the most convoluted to put in place. But it usually is the best metrics. So going on to explanations. This shows you, so the features about it earlier, so the blood serums, the blood pressure, disease progression. When the model, this ensemble we've got, was going through and kind of making predictions, it tells you how important each variable we had was in making that final prediction. And we can see this blood serum level here, blood pressure and disease progression. It's holding about 67% of the decision making. They're really important variables in terms of predicting sex in this model. So it's, for one, a useful thing to know, but also in terms of streamlining a model, we want to have as little variables as possible in there for the model. In terms of, you can improve performance by reducing the selection of features in there, but also for an end user, it makes computation easy, and it also makes the data collection for stuff to put in for predictions easier as well. So it's a useful kind of screen to kind of come through and see how the features are performing in terms of making predictions. The most important screen here is metrics, and there's a lot of stuff there. I'll go for it brief in terms of what the most important bits are. So accuracy is just how many times was a model correct in predicting a male and female. And there's a kind of a table later on I'll talk you through to understand that a bit better. AUC is quite well used in terms of machine learning and data science kind of world for kind of knowing how well your model's predicted. It's intrinsically linked to this graph here, so an ROC graph, and AUC standing for area under the curve. So we've collected here the ROC curve is true positive rate. So that's how many true positive. So when we've said it's a male, and it is a male, as a percentage for the positives, and the false positive rate is when we said it's a male when it's really a female. So it's kind of saying, is this a 1 or not? And when we said a 1 is actually a 2, it's that graph there. And ideally, we want to always be correct in this. So you got the ideal line here. And this line here indicates a coin flip. Sorry about that. Sorry about that. And this is a coin flip, which is a kind of a 50-50 choice of saying, is this male or not? You flipped a coin and you said 1 or 2. And ideally, we always want to be above this line. We always want to be above 50% for this area under curve. Yeah, so these are the two main metrics you're going to want to see when you're going through this. And accuracy is intrinsically linked to something called a confusion matrix, which is here. This indicates everything you've predicted to be a 1, and it was actually a 1. And here, everything you predict to be a 2, and it was actually a 2. So we're always looking for high numbers here and for darker colors here, because that indicates a kind of a strong relationship. You want these to be as small as possible, because this is where we've predicted a female, a 2, and we've actually been 1. So it's useful kind of graph to see how you performed, and it kind of does it quite intuitively for you to see performance here. Okay, and the last bit I'll get onto is up here. So in here, this is where you can get a Python script. So this is the learning bit. Where you can kind of go through and see what it's done, where it's setting up experiments. Like I said, it's very convoluted and it's long, but you can pick out a bit. So here it's setting up a gradient boosting classifier. And it's kind of going through sort of pipelines. You can see the good practice where it's setting up scalars, setting up the classifiers. So it's something, if you get into this, it's useful to go through and kind of see that. Okay, so we're happy with this model. It's done pretty well based on these metrics. I think anything above 50% is great, because that's more than just randomly guessing. But 70 is usually a baseline for what is a good model. It's not too high, it's not too low. So we're happy with it and want to deploy it. To do so, we can come here, and because you use AutoML, there's a lot of steps jumped out. Stuff I can talk about if you want to in the chat afterwards in the question section. But we can click deploy to web service here. So basically, it's deploying to an API, a container instance, and you just give it a name. And it's always best practice to give it a description as well, just so later on you kind of know what this is, what's coming on, and future you will really thank you for kind of giving that extra information. So when you've done that, you can click deploy. We're not going to do that because I've already done it for us in the background. And this is usually what you get up when you've successfully deployed your model. So the two main things you want to see here is test and consume. Test. So this is kind of, you could put in numbers here intrinsically for like a new patient if you want to see what the sex is in our imaginary use case here, and you click test, it'll give you a number out, a 1 or a 2 for male or female. And you can also say it's in JSON format, which is the most important for anyone familiar with an API. Usually we send a JSON with our information in as a pay packet, a payload to our API service, and it'll give us back a JSON with a result in. In this case, it would send back a 1 or a 2. And it's important because when we get to the VBA later on, we need to recreate and create the JSON based on data inputted to send to our API. For consume, this is just useful for kind of a hack to implement our model and to get access to it. If you're using C#, Python, or R, it gives the code already. But all we need for the VBA is the location of our endpoint, so the REST endpoint there. So we'll be using that later on. I'll kind of show you where that comes into place. So that's where we've got to with the endpoint deployment. And I'll just quickly show you a VS Code example. So those unfamiliar with VS Code, it's kind of just a user interface for using various bits of code, etc., which you can get extensions for, which are like add-ons. The VS Code one, we use an example here. It kind of comes in. It'll ask you to log into your Azure ML with using your Windows credentials, and it'll ask you, and hopefully it'll do this now. Yeah, what kind of subscription you're going for, and your resource groups sit below the subscriptions. So it takes you through to your workspace, etc., where your computer setup, etc., and you connect to. And a lot of this you can get through. Here's a Windows example for a credit card fraud classification that I've kind of taken off Windows kind of documents. So here it's kind of bringing in any libraries you need, setting up stuff, and it's taking from your login stuff, your subscription IDs and information we need to run the experiment. Here earlier, you can use via code kind of set up your compute resources here. You can bring your data, etc. here, set up your AutoML and get runs going here. So just to emphasize the power of this is you can put all this in for loops, automate it, and set up 10 experiments to run in the background, vary themselves a little bit by little bit as you go through, or you can get it to set up 3 different computes and run it on these 3 different things. So that is the power of using the code. You can automate a lot more of it. You can set up a lot more to do and kind of go for loops and very much go along with something you'd have to do iteratively in the GUI, the Machine Learning Studio. You'd have to do one run, do the changes you want to do the next run. But you can set it all up here, and you can output different metrics here as well, analyze results in the window. And you can also specify your own metrics in this case, in terms of what you want to see and what's useful for you to see. So if you're familiar with Azure ML or you're already familiar with Python, just Google AutoML VS Code examples, and you can get this sort of stuff. Or I can, if you email me, I can find stuff out for you. And it's useful to kind of do this kind of viewpoint in terms of if you're getting quite serious with AutoML machine learning in general. Yeah, VS Code. If you're more experienced, it's better to go through the code-based approach. But if you're just learning, and also if you're doing little experiments, the Machine Learning Studio kind of GUI interface is more acceptable. Okay, so moving on to the rest of the presentation. Common workflow. So I say as we go for this, in terms of machine learning, it always starts off with a question is asked. And we need to make sure that question is specific enough and will give us an output at the end which is satisfactory to what we were looking for. So an example here, if a customer came to me and was like, I want to know how well my stores are going to perform next year, make my model predict this, I'd come back and say, well, you're not being specific enough for that question. Right, what do you want to know? Is it the amount of footfall? Is it the profit? Is it just the amount of customers coming through, the amount of items sold? So it's more how we measure success in that case, and being quite specific about what we want to predict and what we want to measure. So a lot of the work goes in terms of thinking before experiment to what we actually want and what we can achieve, being the first step. And then from the data that customer's given me, we scan it. Have we got enough data there? Is it from our industry knowledge or working with the user? Is there enough stuff there to kind of go through and make decisions from? Do we know it's going to be useful enough and it's going to be enough there to be worthwhile to go ahead, or do we need to go and get more data in? When we're happy with that, we generate features. So we'll go through and put stuff over time. So make amount of customers in a day, could do it over hours, etc. Combining features, kind of dropping features, scaling features, pre-processing as well. So this is where we can have got filters in to impute values. So it's where we've got missing values. It's kind of, do we want to fill them in, or are they true kind of data points? We'll keep them in there. Do we want to turn categorical variables into numbers, which we nearly always do, because machine learning algorithms, they don't understand words. They need numbers really. So stuff where we've got a high, medium, low as the feature, we need to impute them to say ones, twos, and threes. So that's an important part of pre-processing. Is what you kind of put into the models is what you're going to get out as the common adage it says, and it's very important here for machine learning. Then we then experiment with algorithms in terms of trying different ones and see what we get and tuning high parameters. And we test the final model that we get out. We can be happy or we cannot be happy with this. And usually we're not 30 times, 3 times, 4 times, maybe even 10 times. So it is a cycle where we get to the end, we're happy, and we go back and we start again, we're generating new features, different pre-processing, different experimentation. But when we are happy, we put in production and we're continuously testing to make sure the model we have put in place is still doing the job we want it to do. And when it's not the case, we can go back and we retrain the model, we get new data in. But visually, this is the part that the AutoML is automating for us, is that pre-processing and the experiment of algorithms. And as I said again, it's where we spend most of our time as data scientists is working here and kind of going through and set up experiments and kind of checking metrics and tweaking. And it's kind of, it's a time saver. It's a massive time saver. Just to summarize, and I thought I'd just leave you that kind of visual representation of what AutoML is actually doing in terms of the whole scheme of a machine learning workflow. So for the final demo, using our output in Excel. So this shouldn't be a long one. So I've made why can't that come up? Give me a second, I'm some technical difficulty, sorry. Okay, sorry about that. So here is our Excel code tool, which we're going to get our data from and into. So in the background of this, we've gone for the VBA. Here. And using those kind of fields I've put there, we're going to go through and we're going to get the information we've put in and create that JSON. And we're going to send it to the web service we deployed earlier. And we're going to get back a result. I said it's 1s or 2s. So there's a quick conversion bit there where we're going to say male or female. And then it's going to split it into that kind of a section at the end once I've clicked the button. And it'll do that line by line and kind of show us. And here's the actual body of it, where we're taking our JSON we created and we're sending it to the location of our web service. So I've inputted some random data here, and it's going to output here the sex at the end. So what it's doing now is going through, it's creating the JSONs, it's pinging it off our web API model earlier, and it's come through, and it's gone female, female, male, male. Just to show you how easy it can be to kind of use models and put it in the hands of our end users. I mean, this is something you can create very quickly, and as you saw from the VBA code, then it's very small. And if you're interested in me sending that over for you to play with, just drop me an email. I can send it over. This whole kind of tool in general, it's quite simple and bare bones, but it's putting that ML model in the hands of users and showing how easy everything can be. So going back to the demo again, the presentation, that's the end. I'm happy to say. So if you've got any questions, I'm happy to ask them, answer them now. Just there's my social medias again. So LinkedIn, a QR code which will take you to my LinkedIn, my Twitter, and my Gmail. So if there's any questions, I'm happy to take them now.
Very common, quiet, no questions, but you had a lot there. There was a lot of content, and I really, really appreciate it. We do have a comment, the best kind of comment, right?
Yeah.
Alex says, great session. Thanks, Lewis.
Yeah, it's great. I suppose there's no questions then. But if you've got anything you want to ask me, obviously I'll be on LinkedIn, email me, I'll be on Twitter, send the messages. I'm more than happy to spend time to talk to you guys all, and kind of go through stuff. Yeah. And just to end it off, I said these are 2 blogs I've written on which is everything from the start to the end, AutoML, how to use it and why, is all the way up to deploying the web service. And the second one there, Consuming Excel, is everything in detail from that web service to creating the VBA. So those 2 QR codes will take you to the blog posts for you to read at your leisure. But it'll go a lot more in depth than I've given in this talk, as well as a background to machine learning and AutoML. And I said I'll show you how to create the computes and set up Azure Machine Learning Studio. So if you're really interested, there's probably a starting point, I would say, to get you right into it, to recreate what I've done today.